For a decade, artificial intelligence was seen as a cloud-bound force requiring massive data centers and continuous network connections to function. Now, a silent revolution is underway. Powerful language models are moving directly onto your personal devices, offering personal, completely private, and instant intelligence without needing the cloud. Cloud-only AI models introduce significant latency, privacy risks, high subscription costs, and unreliable offline access. To break past these structural limitations, computational intelligence must move to the edge, running locally on user hardware to ensure that AI remains reliable, secure, and fast under any conditions. Today's smartphones and laptops possess more raw computational power than the supercomputers of past decades. On-device AI utilizes this local power to offer zero-latency responses, privacy by design, and deeply personalized learning without ever exposing your private data to external servers or cloud providers. This local processing model ensures that your user context remains fully yours, protecting sensitive files and interactions. Small language models are purpose-built from the ground up for edge deployment. Through efficient architecture design and high-quality training datasets, these compact models deliver incredibly strong reasoning capabilities in megabytes rather than gigabytes, proving that parameter size is not the only measure of model intelligence. A rapidly growing ecosystem of hardware accelerators, optimized runtime software, and open-source models enables edge AI. The question is no longer whether we can run intelligence locally, but what highly responsive and secure applications you will build on top of this powerful, untethered edge foundation. Efficient model architectures like grouped query attention and mixture of experts allow small models to reason like their larger counterparts. By optimizing every parameter and reducing memory bandwidth bottlenecks, these local architectures maximize inference throughput while minimizing the power consumption of local hardware devices. Quantization, knowledge distillation, and network pruning are the core techniques used to shrink large models while preserving their reasoning performance. Through these methods, a massive 70 billion parameter model can be compressed into a highly efficient 1 billion parameter model, retaining over 90% of its capability. Modern silicon chips integrate dedicated AI accelerators and neural processing units directly into consumer hardware. This integration enables extremely fast, low-power inference, turning every smartphone and laptop into a private, always available AI server that can run advanced models without draining your battery. The development pipeline is fully automated and scalable. A large teacher model is used to train a smaller student model, which is then quantized, validated for accuracy loss, and compiled for target hardware. This ensures seamless deployment from high-end cloud systems to local consumer devices. Local small language models can respond to user queries in under 300 milliseconds, enabling fluid, real-time voice interactions and responsive UI elements. By removing network round trips, on-device AI makes human-machine interaction feel completely natural, spontaneous, and immediate. Instant feedback loops make complex workflows like live transcription and translation feel smooth, highly interactive, and completely fluid. On-device AI ensures privacy by default at the physical layer. Because no user data leaves the device to be processed in the cloud, complying with strict data privacy regulations like GDPR and HIPAA becomes simple, secure, and immune to server-side breaches. Local models can continuously learn from your daily behavior, documents, and preferences, adapting to your style without compromising privacy. This creates a deeply personalized assistant that understands your personal context intimately while keeping that knowledge strictly within your own physical device. As AI moves to the edge, traditional academic benchmarks are replaced by real-world operational metrics. Performance is measured by token generation speed, memory footprint, thermal impact, battery consumption, and user satisfaction, redefining what it means to build an efficient edge-native system. From real-time offline translation to local secure code auto-completion, small language models are powering a new class of applications. These tools work completely offline in remote areas, process sensitive enterprise documents securely, and deliver results instantly, transforming everyday mobile workflows. The edge computing spectrum spans from tiny microcontrollers in smart home appliances to premium flagship smartphones and workstations. AI models are tailored to each specific device's hardware, balance computational constraints with performance, and scale intelligence across the entire physical environment. Edge software development kits and runtimes simplify the local deployment process. Developers can write their application logic once and deploy models across iOS, Android, and Windows systems, eliminating the need to manage complex cloud server infrastructure or pay variable API usage fees. For enterprises, on-device AI reduces cloud server costs, improves data privacy compliance, and enables new business models. By unbundling intelligence from cloud infrastructure, companies can deliver reliable, private AI experiences at a fraction of the traditional cost. The future of computing belongs to hybrid intelligence architectures. A local orchestrator runs daily tasks and privacy-sensitive queries on local small language models, automatically routing complex tasks to cloud models only when necessary, balancing speed, privacy, and reasoning depth. Local models handle raw sensory filtering, while cloud services are called only for high complexity synthesis, saving network bandwidth and token costs. Billions of personal devices are becoming hosts to local AI, forming a highly distributed network of learning systems. This decentralized intelligence fabric scales globally, reducing the environmental footprint of centralized data centers while empowering individual users with private cognitive assistance. The structural shift to edge intelligence is complete. We must start building with small local models, demand on-device capabilities to protect data privacy, and embrace a future where power and intelligence reside in the palm of your hand, not in the cloud.